In this video, you're going to learn how to detect malicious senders in emails and understand how MIME, SMTP, and spam work. So you see here, I have Mac Mail open on the top left. Bottom left, I've got Thunderbird. Top right, I've got Outlook. And the bottom right, I'm using Google from a web browser. They're all the same email, and this is a spam email. Obviously, when you look at it, it's quite ugly, so you kind of get the idea that it's probably spam. But hey, this is coming from La Poste, and that's a French postal service, and I'm in France, and I see that that might actually be quite interesting to me, right? But the problem is, this is not actually coming from La Poste. It's coming from some bizarre person, you know? And so in this video, we're going to talk about how to detect malicious senders. We're going to talk about MIME, which is in the header of emails when they're sent and received. I'm going to talk about a few more things. So let's take a look. So in Mac Mail, and by the way, you really should never have your preview open because you might accidentally click on something. Something might accidentally load. I'm going to talk about that later on in this video. But the way you do it in the Mac is you click on the mail itself, and you go up into your menu bar. You're going to click View, go down to Message, and there's an option for raw source. So you're going to click on that. It's going to open up the raw source of the email. What I did is created a text file and a code editor. Here it is. And so I just made it bigger so it's easier to read. That's actually the code, essentially, or in the text of the email. Right? We see just a lot of bizarre stuff. I'm going to dive into the headers in just a minute. But before we go there, I'm going to show you how to do the same thing in Outlook. Outlook is a bit different. You just right-click and go to View Source. Quite simple. And for Thunderbird, you're going to click More, and you're going to want to select View Source. In Gmail, it's a little bit different. You're just going to click More here and go to, where is it? Show Source. Oh, that's a nice little feature. You can report these guys as spam or phishing. That's really cool. What's nice is look at that. Look at that. They decode the Base64. What these guys are doing is they're using Base64 to hide the fact that they're actually coming from this email address. The mail client in the Mac is a little bit different, so we can't really see it without clicking here. But that's quite interesting. And I know they're using Base64 because that's the way that you would do this. I can send anybody an email coming from Steve Jobs, right, and just put Steve Jobs here. But it's not actually coming from Steve Jobs. It's coming from a different mail server. But the mail client will actually interpret it differently. So let's talk about the SMTP handoff. So emails need really just a couple things, a couple records to ensure that they don't end up in your spam mailbox. They need an SPF record, DKIM, DMARC, and notably a PTR record, which stands for a pointer record. And if you don't have that, mail servers in the SMTP exchange, like Google and really most well-known servers, well, they're just going to reject your email. Right? And the reason why is because the PTR record is used to map the IP address, so the IP address of the server, to a domain name. While PTR records themselves are not directly related to email delivery, they play a role in the overall email authentication process, specifically for ensuring reverse DNS lookups match forward DNS lookups. And this is important because if you don't have a PTR record, well, well-known servers are just going to reject the emails that you're sending. So PTR records are really the cornerstone of mail servers. So how does it work when you send an email? So I just showed you a few different email clients like Mac Mail, Outlook, Thunderbird. And those are actually applications on my machine. And that's kind of cool, right? You've got an application to access the mail server. But the problem with that is what you don't know, is that you're actually exchanging your credentials over and over and over again to authenticate with the remote server. Now, if you've ever built a mail server and looked at the logs, you'll know this, right? Through the IMAP protocol, which stands for Internet Message Access Protocol, what's happening is you're constantly over and over and over again hitting the server. And that creates a lot of noise. And I don't like noise because a lot of noise means that your attack surface increases, right? So kind of the better way, and I'm not promoting Google at all, as a web browser or a mail client or mail service. I'm just saying that, if you're going through a web browser, it's going to be a bit better because your credentials are going to be stored in a type of, maybe in a cookie or however else it is designed by the developer of the service. And instead of going through like an IMAP protocol through a intermediary, you're going to be going directly on to their server and accessing the mail directly. Now that's really, really cool. And the reason why that's cool, if you've ever looked into mail logs and really into MIME, what's great is that you're actually not giving up a lot of information about your machine. Now, this might change in time, as mail clients evolve. But as of today, if you create a mail server, you build one yourself, or if you're using some sort of third-party service, when you send an email, it's very dangerous. When you send an email to a recipient, you depending on the mail client, you could be giving up your public IP address, your private IP address, information about your mail client itself, the version, and maybe even some information about your operating system. So that's really not good. And so when you send an email, you're going through, so you're going through the IMAP protocol in most cases to authenticate with the mail server. And the SMTP connector, and in most cases it's Postfix, right? It's just your mail transfer agent, is going to be stamping that email and appending information to the MIME, right? And this is the reason why, here I'll show you. This is the reason why emails are a legal proof of information, because they're going through two different, probably, in most cases, two different mail servers, but not limited to that, right? An email can go through many, many different servers, and that's why you have headers like ARC and other types of validation steps in the process. And I'll talk about that a little bit later. But essentially, this comes from the start and then the endpoint. So I'm receiving it on my Google account. So this is an example of a relay host, and a relay host is essentially a server that has the right to send an email, to send an email on behalf of another server. And so when you're looking into the logs, the output's not going to be nearly as much as you would have if you were to have built your server yourself with Postfix and a number of other different technologies to have access to your mail through a web client. But what I see here, and what you're going to see here, is just some information around the mail ID, the user that actually sent it, because basically it's just a user on the machine. And in this case, it's Linux, and Linux is awesome, right? Got our message ID, and this is coming from Postfix as our MTA. We've got the user and the host with some information around the size. Going to the active queue, we're going to see that we're going through a relay process, basically connecting to Google, their mail server through the SMTP protocol. And we're going to be hitting their IPv4. There might be some delay, DNS information. Looks like a 250. It's a 200 response. It's an OK, meaning that Google's server tagged the mail, apparently, and then was able to send it. And I'm getting information back from their server saying that the information, or the email, was actually sent. And then you have queue manager. So basically what Postfix does is if an email bounces, so I send an email, I don't hit the mail, the recipient mail server, maybe because either it doesn't exist or because the recipient doesn't exist. So what's going to happen is that email is going to go back into a queue, and the system's going to try to send that email, again and again and again to the recipient mail server, at least as best as it can, depending on how you have your system set up in your configuration. And if it doesn't actually get to the recipient's mail server, then you're going to get an email back from daemon at whatever, relating to the fact that the mail was actually never delivered. So when the email is actually getting sent, MIME information will be appended to the mail that gets sent to the recipient's mail server. Their SMTP connector, their MTA, their mail transfer agent, is then going to also append information to the header section of the email, to the MIME. And then your recipient might access that mail through IMAP or some other means to then read that email message. Now, what you might not know is that when you're actually reading an email, the moment you click on an email, this is really kind of cool, actually. When you click on an email from your mail client, whether it be Mac Mail or whatever, but I'm not really sure actually how this works with a web browser, but I know that, oh no, it does, it's the same. Yeah, it's the same. Basically, whenever you click on your mail, there's going to be information appended to that mail behind the scenes, noting that you clicked on it. You read the email, right? And it's going to change some information in the mail message itself, wherever it lives on the server that it lives. So that's actually kind of cool. And again, emails it's a legal proof that information was sent from somewhere and received from somewhere, and that someone clicked on somewhere. So, when it comes to email, you just got to be really careful what you're doing, because everything you're doing is being tracked and recorded and logged away somewhere, okay? So let's talk about MIME. Okay, so MIME is an integral part of kind of all of this, right? MIME is an acronym for Multipurpose Internet Mail Extensions. And MIME, including support for images, was first introduced in the 90s, right? A long time ago. Relevant specifications for handling images in MIME were outlined in the RFC 1521. And this was published actually in the early 90s. I think it was like 93. And so MIME is kind of, a standard that extends the format of email messages. Now, you might think that people can execute malicious code, and that's actually kind of true. In a way, it just depends on the mail client. So JavaScript is typically not directly used in MIME. However, JavaScript can be included in HTML, and this guy includes some HTML here. And so JavaScript can be included in HTML content within the email, but its execution might be restricted due to security concerns with the mail client. So whatever mail client you're using, and I think most mail clients are probably going to restrict JavaScript. And I don't think I see any JavaScript in here. I can just do a search for script, but I won't do that. Anyways, and so why is all this important? This is important, right? Because emails can include a lot of stuff like HTML. And HTML, which stands for Hypertext Markup Language, was incorporated into the MIME also in the early 90s, right after that that standard got released, the RFC 1521. This is in 93. It's a long time ago, right? And so although browsers don't really compile HTML in the traditional sense, instead they interpret and render HTML. So when you load a web page, the browser's just using its rendering engine to process the HTML and parse the document structure and then render it visually so that you can see it on your screen, right? Now email clients, well, they do the same thing. And although that's cool, it also increases the attack surface because hackers love a larger attack surface. So let's talk about steganography. Steganography, in digital terms, because this has been around for thousands of years. But in the digital world, it's really only been around since the 90s. So researchers and practitioners began exploring ways to embed hidden information within inside of digital images. And the digital domain really offered new possibilities to conceal data within the least significant sort of bits, of an image file, exploiting the imperceptible changes in color values. And the discovery and development of digital steganography techniques have continued to really advance since then, with the ongoing advancements in both concealing and detecting hidden information within various types of digital media. Now, this is scary stuff because, when you click on something coming from an Amazon server or whatever, when you click on something, you might actually download it. And if you download it to your machine, that can actually then be used on your machine to then run some malicious code. And so there are some file formats you really want to watch out for, notably .pif, a .pif for Windows machines. You can be looking for a .exe, a .com, a .cmd, a .bat, a .vb, .vba, vbs, .msi. There are a lot of different extensions you need to be really careful with when working with, especially with Windows machines, because Microsoft is, well, it's a big domain, right? So the bigger the domain, the more options that attackers have to exploit machines. So this is why it's really important to pay very close attention to what you're looking at. Don't do what I did, right? You want to hide your preview. You don't want to be exposing anything. You don't want to be loading anything inside of your mail client. And really, you don't want to be using mail clients at all because, well, they're terrible. They're giving away information about you, and you need to be very careful when it comes to email. Okay, so let's talk about these different headers that you're going to see in an email. So like I said before, this is happening in reverse. So this is the recipient. This is me receiving the email. And the first part here, really the second part, is the sender. So it's the sender's information while they're sending the information, their email to me from their mail server, and then I'm receiving it up here. And so this is not a standard header. Every header that starts with an X is not a standard header. This is something that it looks to be, obviously created by Google, right? So I'm receiving this on my Gmail. And this is a mail header. It looks like just a way that Google is tagging the email, maybe like a unique ID. That then they store in their database so that they have something to reference it from. So when the government comes knocking on your door going, hey, there was an email that you received. Oh, yeah, that one with this ID? Well, how else can they have that, right? Okay, next you have X received. Again, this is a non-standard header coming from Google. This looks like it might be an IPv6 with SMTP, which is a transfer protocol, which stands for Simple Mail Transfer Protocol. And then some other ID as it relates to however Google is handling this in the back end. So next we have the ARC seal. The ARC stands for Authentication-Result Chain. And this is a protocol extension designed to help protect email senders and recipients from forgery and phishing attacks. And this is obviously a phishing attack. And it's just there to provide more information about the authenticity of email messages. So just think of this like a signature, a digital signature of Google going, yes, I received this mail. And I received it from just one mail server, right? And this is where the I comes into place. And I'm going to talk about that in just a second. But before I get there, I'm going to talk about the ARC message signature. So the ARC message signature is there to provide a means of verifying the authenticity and integrity of the entire ARC chain, right? It helps ensure that the email was not tampered with and the information about the messages handling, and authentication status is actually trustworthy. And that, again, is where we have the way that it's been encrypted, our domain, and some other information like our iStatus here. Okay, getting into that iStatus, the iIndicator actually is a parameter in the header that denotes the instance of the ARC check. And so basically it's just a numeric value that increases for each intermediary in the delivery path. So say this email goes through a couple different like forwarding services and mailing lists or whatever. Well, this number won't be a 1. Right? It'll be very different. And that's actually really helpful for you when you're reading your MIME to know, like, hey, I've got like a 10 here. Okay, well, that email had probably bounced around a few times before you actually received it. And that's the reason why ARC is so important, right? We're actually validating the trustworthiness of this email. Okay, so next we've got the ARC-Authentication-Results. And this header includes information about the authentication results at each step of the delivery process, especially when messages pass through intermediaries like mailing list servers. So you might expect to see a little bit more than just an SPF record here. Notably, I would hope to see a DKIM pass. I would hope to see an ARC pass. I would hope to see a DMARC pass, but I'm only getting their SPF. Now, that could be the reason why this email would go into spam, or maybe it wouldn't go into spam, depending on the validation process. Also, there are a lot of different things that depends on the how recently this server was created. This mail server was created. Does this mail server have certain ports open? So there are some like machine learning tactics that mail service providers like Google will employ to validate the server itself as legitimate or not, based on maybe their DNS records, based on the legitimacy of this server. How new is the server? Is it a brand new server that was just created? Based on the record that's associated to it, the FQDN. Is the FQDN is it new? Was it created within the last few weeks or a few years? Has it been around a long time? I'm not really sure how Google does it, but there are some more advanced tactics for service providers to exploit. So next we get to our return path, and although you might think that I received this email from this person, you would be totally wrong. The return path header specifies that the email address, which delivery status notifications, DNS, or bounce messages should be sent to if there is an issue with the delivery of the email. Now, we talked about that before. My sender is going to be sending the email. If the server doesn't exist, or if the recipient doesn't exist, well, then I'm going to get a bounce, right? And so we need to then send that bounce back to this address, and this is set by the sender. Okay, next is received, and this is where everything becomes clear, right? So in received, this is a standard header used in email messages. It's not a header that's actually specific to MIME. It's a header that is added by each mail server that processes the email. So if you're looking at received, everything will be confirmed. Getting it from Farntown, and I'm going to dig into these guys in just a second. Coming from this IPv4, that's a mail server. You can't proxy this information. You can't proxy because you need to know where to send the email, right? It needs to go to a very specific IPv4 address. That's just the way mail servers work, and that's the way they've worked for a long time. And this is the looks like the reverse of their server here, and they're sending it to me at this Gmail account. And the reason why you see a different Gmail account here that you saw in my mail clients earlier is because I just sent it from the crap email, the clone email account, to this email account. Actually, no, that's actually the reverse. I received it on this Gmail, and I sent it to the other one. Okay, anyways, so we have some more information here. It's really easy to create an SPF record. SPF stands for the Sender Policy Framework, if I'm not mistaken. And that's really easy to say. You just set a text record in your DNS, and then make sure that you have the same record on your mail server. So I see this is base64, and I know it's base64 because it looks like base64, and it's in UTF-8, the base64 marker. Here's the text. I'm just going to copy this, and I'm just going to write this text out here in the terminal. I'm going to decode this base64. I'm just going to pipe out my base64 and decode. So it looks like it's coming from La Poste, right? We saw that earlier in the mail client, right? You see it here. They're trying to say, hey, I'm coming from the postal service. Pick up your package. Click this link, right? But it's actually not coming from them. It's coming from this FQDN, so BTF CP, at least that's what they're saying, .us, which is our TLD, our top-level domain, and that's the user. So I'm pretty curious about who these guys are. I'm just going to copy and paste this. Okay, looks like they're using port 80, which is a standard web port, unencrypted. They are on their server, their IPv4 here, this server. They're offering also 443. It's a port that's open. That's a standard HTTPS port for encrypted web traffic. And that looks like SMTP. So, looks like a mail server to me. So if you want to report these guys, this is their server. But that's not actually their registrar, because you can have a server and a registrar, and the registrar be somewhere else, and the server be somewhere else. But if you do want to dig into these guys, you can who is them and get some more information around the hosting provider, and then you can contact the hosting provider and say, hey, you know, I received some spam from this mail server. Can you do something about it? Because obviously, when they sign their contract to then pay for the server, they are agreeing to a certain set of rules and regulations that they need to follow. And if they don't follow those rules and regulations, well, they don't deserve services. So I see the domain that they're using was Farntown. There it is right there. Farntown. So I'm really curious about this domain here. I'm going to who is Farntown. Who is Farntown? And again, this is the registrar where they purchased their domain. Very different from our server. And there's some information about abuse that you can dig into. Sorry, my screen is, the text is really big, but I did that so you can easily see. So registrar abuse contact, they're from Namecheap, right? They bought their domain on Namecheap. Namecheap is awesome. The names are pretty cheap, right? And anyways, and so you can contact Namecheap and say, hey, you know, this Farntown, they sent me some pretty nasty stuff in my mailbox. You can give them access to that email that they sent to you, and you can report them, because, you know, that's why registrars exist. They're here to help people follow the rules, right? And if they don't follow the rules, then you can report them. So report them, and you have the email address of the registrar here to report the malicious sender. So I want a little bit more information. I'm just going to dig short on Farntown, and yes, this is the same IPv4, and they're not even using it like a CDN or anything. These guys are so stupid. They're not proxying their traffic to the website. This is the same. I think it's the same. Let's just copy and paste it. Let's copy and paste it like that. Yeah, it's the same server. Exact same server. So these guys don't have a DMARC record, but you can verify that by digging into their DNS. So it'd be dig.txt. It's typically just called DMARC, right? .domain. So in this case, farntown.com. And I'm going to grep out DMARC. So I don't see anything. But what they should have done is set up a DMARC record and a DKIM. I'll show you an example of what that should look like. Right. So I actually get the record from my DNS saying, hey, there's a DMARC record set up and associated to this email account. It's just good practice to have the proper records for sending out emails. And so in this mail that they sent me, this nasty mail, I saw something that gives me a little bit of excitement. So this Google API here, what you can do is just copy that, and then I'm going to go back to my Google browser, make this a little bit bigger so you can see. Google's got this website where you can report malicious, you know, baddies. So I'm going to call out developers.google.com, and this is search help report quality issues. That should be right. So here we can report spam, we can report malware, report phishing. I'm going to click spam, and I can just paste in that URL that they're using, right? You can also just go to report phishing and then paste in the URL and say, hey, these guys are using this URL, and who knows what they're using it for. They might be using it to get some statistics on the machine that's clicking on their email, right? It's a type of reconnaissance. But in any case, you just need to be careful, because whatever you click on, well, that's being logged somewhere in a server, and that's quite dangerous for you. Doesn't look like there's a whole lot of dangerous stuff in this email. It's just text and HTML. Looks like it might just be reconnaissance, and they're just trying to get information about my machine. So that was fun. I hope you learned something. Just a quick recap. In this video, I showed you how to detect malicious senders by reading the MIME. I also explained what MIME is, and I explained a bit of the SMTP handoff. Talked about headers that you might find in emails. You learned a little bit about the history of MIME and HTML in mail messages. I showed you how to dig up some information in the DNS of your choice. I also showed you how to decode Base64 and how to report bad people for doing bad things. So lastly, before I sign off, we didn't talk about spam and how it works, right? So mail servers will actually use databases in most cases. Like Google might be using a database or a series of databases to validate an email before you receive it in your inbox. And that's kind of like an old tactic. But more advanced service providers will be using machine learning around content analysis to identify and block spam. Spammers are constantly changing their tactics, and this makes it actually quite difficult. But you can just Google the words known, I could spell that correctly, known spam databases. And no, gosh, Google, you're terrible. Databases list. Okay, and you get a couple of different spam databases. Barracuda is pretty well known. Spamhaus, obviously. Yeah, so you've got some. There's a lot more than this, but this is just a really small example of the well-known spam database lists. Well, I hope you enjoyed this video. Stay tuned for more.